Assalamu Alaikum everyone, I'm Ahmed Bukar and welcome back. So in this video I'm gonna teach you what artificial intelligence actually is. So we're gonna learn the core concept of artificial intelligence. So here I have a photo. I'm gonna edit it with paint. I have it over here. I'm gonna zoom in. Okay, so this is much better. So here we have something that we have always been learning and still we learn this, and this is input process output, input processing output. This is very similar to you. You have been learning this for a very long time. It's your first classes. I hope so. So what this model actually does is it takes an input, processes it, and then outputs our data. What does it output now? Now it processes our input. Now let's say we in the input we have given a 1, in the number 1. In the input we have given the number 1, and in the processing we want to uh, add a 1 with that. I use the brush, pencil, or what? Use the brush. So I want to add a 1 with the input. So here I have put a 1 in the input, processed it, added a 1. This is a function that we create by ourselves. This is a function that we create ourselves, and we get the output 2. This was our raw data, this was our processing data, and this was our output. So this is actually how modern computers work. So this is the basics of what you have been learning all through this time, and now I'm gonna tell you what artificial intelligence actually does. When you use an artificial intelligence software on anything, when a programmer creates a artificial intelligence software, he doesn't have to do anything with the process. He doesn't have to create anything for the processing. He would just cross it out. He would only use input and output. He would just give an input, and the software itself would give an output. Interesting? Really interesting. Why not processing? Now, for example, I am going to give a 1 to the input, and the artificial intelligence program would create the function itself. I won't give it a function of +1 myself. The artificial intelligence program would create that function itself. It would create the rules to set the function itself, and then provide our output as 2. Now this is very mouthful, very advanced, but this is the core concept of artificial intelligence. Now there are 3 stages of artificial intelligence: train, test, and run. Now in training artificial models, you have to create a model where you're gonna train it using different inputs and outputs. So let us name this place training model. Ready. So this is our training model. So what we do in our training model is we provide an input and an output, both. We provide an input and an output, both, and the artificial intelligence model would itself use these two inputs and outputs to make its processing rules and functions. Now I can add more inputs and outputs. Now here I am not adding, I think not adding, 2, 3, 3, 4. I'm using a mouse, that's why bear with my kind of handwriting. I'm using a mouse. So here we provide three inputs. No, not three inputs. We have three stages in the training model. First, we provide one as the input and two as the output. Now, the artificial intelligence training model would train it. The model would train itself to make a function, make a rule that is going to make that a function that is going to make the input one uh, process and then output as two. So this is basically artificial intelligence, and it's really advanced. I'll tell you the live applications, live applications in throughout the world, how this has been helping scientists and many others throughout the history, throughout the 40 years till now. Then throughout the training model, training process, we give the input 2 and output 3. So this is again going to put a function, a process. Now why more than one stages? Because sometimes the artificial intelligence training model won't be able to create perfect, you can say perfect, um, perfect models. It won't be able to create perfect functions and rules. That is why we use this. We use multiple types of inputs and we also use their outputs. So here I have my training model and it's done. So next I have my testing model. What does testing of artificial intelligence programs do is that we give an input, we give an input and an output, and we test how much the artificial intelligence knows that this the function that is it has created can match these two inputs and outputs. Now let me show you how that works. uh, I have provided an input and then as well as output. Now we want the processing stage to spit out how much it can understand that this input and output matches with its rules and functions. So it provides a loss, a and a error, or basically it would only provide a loss. That means how much did the artificial intelligence program didn't understand the input and output. Means if the loss is greater than, if the loss is above 80%, this means we didn't train our model very perfectly. If we just run it right at any time, it would provide 1 and the output as 3, something like this. So the while testing, it shows you how much you should train your data. If you train more, the loss would decrease and below to 30, 20, 10, but it can't be zero. The loss can never be zero. There are scopes, there are many things, many reasons for that. So remove the loss, and here's our test model. Here we tested how much the artificial intelligence in program can't understand the input and output we have given it. Now we have the running program. So we provide a, a input side of our artificial intelligence program, and here we have 10. So after we trained it, we tested it, we are going to use that artificial intelligence program to answer our questions. So we have given 10. It's going to go to the processing, the artificial intelligence stage, where the rules and functions were created by artificial intelligence itself. It's going to be processed and give an output of 11. Now it might use some decimal points because it's not very accurate. Artificial intelligence programs are always not very accurate. You need to use deep learning, deep neural networks, deep machine learning to do that. So here I have my running module. Everything's done. Now let's talk about what what artificial intelligence actually consists of. So let's say so let's say this whole bunch of circle is our artificial intelligence AI, and we have another circle inside of this. Now what this circle is, it is ML. What is ML? ML is machine learning. Now there are three types of machine learning, but we're gonna get to that later on. And inside machine learning, we again have another circle, and this is the most important part of artificial intelligence, and this is called as NN. Only NN. Why not a advanced name such as artificial intelligence, machine learning? It's known as neural network. So it's in neural networks inside of machine learning, inside of artificial intelligence. So you can see how this punches itself in the form of sets. So the neural network is the main thing that creates the functions, the rules that are required to run a artificial intelligence program. So now let us talk about the three types of machine learning, you can say, programs. So there are three types of machine learning processes, you can say, just three types of machine learning. The first one is, let me use text. Oh, what is this? Text. The first one is supervised learning. Supervised learning. Then unsupervised learning, and lastly we have reinforcement learning. Now these three kinds are advanced, they're very useful, they're very helpful. The first of all, let's talk about supervised learning. Now what this supervised learning is that we in supervised learning artificial intelligence program, we provide both the input and the output, and the artificial intelligence programs creates the rules and functions for us, just like how we did before. So it's very basic, it's very great, a powerful tool in machine learning if scientists want to learn something that by taking many examples and then creating new kinds of examples, just like that. Next, we have unsupervised learning. Now, unsupervised learning is the opposite of supervised learning. The difference is that it doesn't contain outputs. We don't have to give the artificial intelligence program any output. This means we just have to provide an input, and the machine learning algorithm would itself generate the rules and functions just to you know create different kinds of attributes for our artificial in for the output. Now I'm going to explain it to you right now. For example, here we have you can say three kinds of fruits: mango, apple, and banana. Now, when we train the images of these fruits to our unsupervised machine learning algorithm, it would generate the output in the form of the common types. For example, the mango, it would separate the mango from the apples and the apples from the bananas and the bananas from the mango. It would do it like this, or it would separate them out through their color. Mango and banana might be the same color, and they would separate, and it would separate it out from the apple. And this is how supervised learning algorithms work. Next, we have reinforcement learning. Now, reinforcement learning is a very advanced kind of learning. It can, but it uses a lot of energy, a lot of data to, a lot of training to make it a lifetime runnable, can say, data. So in reinforcement learning, we don't have to use input processing and output. We just run our training model. We just run our training model and wait for the training model, our training algorithm, to make mistakes and make successes. Now, this is very mouthful. I'm going to just explain to you what this actually does. Now, reinforcement learning can be trained through punishment and rewards. It has loss, punishment, and reward. So, let me just explain you what this actually is. For example, you have a game, Snake. You everyone plays the this snake game. It's very kind of, you can say, a game. Now you want to make that game play by itself and become a master and put a world record and master a world record. Now when you're gonna use the artificial intelligence algorithm of reinforcement learning inside of that snake game, what you're gonna do is just run that snake game, and for the next 10 hours, 12 hours, 20 days, months, years, the next years, the snake game is going to be running, and you're creating your and the artificial intelligence reinforcement learning algorithm would be creating the rules and functions all by itself. So here, let me take you to an example. I don't have a snake game right now, but let's so let's say you run your snake game in this window. You run your snake game. It starts from a random position, and you have your food in a random position. Now, in when the artificial intelligence algorithm would be running, the snake would be going here and there all by itself. And when it hits the wall, it would get a punishment. It would get a less reward, and the snake would remember that, oh yes, this is the place where I got a punishment. I will not go there again. And so the next stage comes up. The next episode, you can say, then a new game, and the snake starts from a random position. The food is at a random position. The snake goes on and on and on until it hits the wall, and so it gets the punishment. But the next time it comes over the same place, it will avoid that. It will make a turn. And uh, so this is how the punishment works. Now how does this reward work? Let us see. Now we had this food over here and our snake over here. Now when the snake just makes a turn all by itself, it goes and goes and goes and goes and eats the food, and it gets a reward. Now the snake would remember that yes, the food is at this position of our window. The food is at this position of our window. So it would again go to that place and take the reward. But instead he would taking his own tail, and the game is over. So the snake would now remember that this uh, snake would become a the snake would become like confused that there was food here a while ago, but then he came upon his tail. Why? The snake would be confused, but we would have to give the snake a lot of training stages for this. So as long as the snake eats food, gets the punishment of eating its tail or hitting the wall, the snake would become more, the artificial intelligence algorithm would become more, you can say, advanced. It would become more master, and at last the snake would fill up your window the blink of an eye when you're running it after a lot of training processes. And one thing to notice here is this reinforcement learning is the high level of machine learning algorithms, and it's really hard to make a, you need to make a game or something like that, train it. Many game technologies today use the reinforcement learning to create uh, mobs or creatures, or just in used in games. You might know the things that move on by themselves without the help of anyone. For example, path learning algorithm, path finding algorithm that is just used to find a certain path to a certain place. So this was our reinforcement learning, and this is it for the three types of machine learning algorithms. This is the end of the video. Meet you guys in a later one. Yes, in a later one or in a later one.